Welcome back, geometry students. We're on page 249 of your student journals. We're on lesson 9.2. So what we're going to talk about today are going to be some special right triangles. And so to be honest with you, these are going to be a couple of the relationships you're going to be learning. This year will, take you into whether you're going into regular algebra 2, honors algebra 2, doesn't matter, pre-calc, honors pre-calc. These kind of relationships are going to be used every year that we do math. So for the rest of your math career, these relationships will come in handy. So today is kind of an important topic. All right, so there's a couple different theorems, and so what we mean by special right triangles, there's two specific kinds of right triangles that have certain relationships that are between the sides of the triangle. So we know in the last section we talked about Pythagorean theorem and how a squared plus b squared equals c squared, and that was a relationship between the sides of all right triangles. Well, this one is specific to certain kinds of triangles. So the first one is called a 45-45-90 triangle. And what that means is that when we say that, we're talking about the angles in the triangle. So obviously the right angle, and then we have two other angles that are acute. And so in this particular one, we know that they're both 5 degrees. So think back to what we learned about angles and sides relationships, right? If these angles are the same, then the sides across of them have to be the same. And so what I normally do is I label my sides as legs, because they're what they're called, the legs of the triangle. The hypotenuse is always the side that's across from the right angle. So I like to label all of my pieces of my triangles. We have, in this particular 45-45-90 triangle, we have a leg, and a hypotenuse. So what we're getting at here is there's a relationship between what you do to get from the legs of a 45-45-90 triangle to a hypotenuse. And so the relationship is, so see how they marked them as x? What you would do, whatever this value is here, if you multiply it by root 2, you get to the length of the hypotenuse. And so then remember that, this kind of can go both ways, right? So if you're given the hypotenuse, and you were asked to go back to the leg, you would do the exact opposite, which is divide by root 2. This is why we're working with a lot of radicals, right? So in trig, you're going to notice, and in higher level math, quadratics, polynomials, and anything above, you're going to be working with a lot of radicals. And so it's going to be, we need to get comfortable multiplying, dividing by radicals, rationalizing denominators, that kind of thing. All right, so let me give you a couple examples of what you might see and when it comes to a 45-45-90 triangle. So whether I give you like a picture or just tell you some relationships, so first of all, I'm just going to give you this information here. So I'm going to say find x and y. So first and foremost, what I want you to pay attention to is the fact that I marked those two sides as congruent. So we call this an isosceles triangle. So because those two sides are congruent, we know this has to be a 45-degree angle, and this has to be a 45-degree angle, okay? So remember, if this is 90, we know all three angles in a triangle add up to 180, which means these two angles have to add up to 90, and since the sides are the same, the angles have to be the same. So without me actually marking the fact that those were 45-degree angles, we knew that based on the markings the congruent marks that I put on here. So then if I'm going to ask you to find x and then I'm going to ask you to find y, well, y is probably the easiest one to find. If this is one of our legs, so I'm just going to label this as a leg, this is a leg, and this is a hypotenuse. Again, the hypotenuse is across from the right angle. We know in a 45-45-90 triangle that the legs have to be the same. So we know that y has to be 5. To get from the leg to the hypotenuse, so to go from a leg to a hypotenuse, doesn't matter which one, you would multiply by root 2. So that's the relationship. So 5 times root 2, I want you to write it like that. So I don't want you to write it as a decimal, I want you to keep it in radical form. So that's kind of how you're going to use those relationships. Let me show you one that's maybe a tad more challenging. So let's say I gave you a triangle, I marked the sides as congruent, and I showed you that it was a right angle, but this time I gave you the hypotenuse. So in this scenario, this one tends to be a little bit more challenging because you have to kind of do a little bit more math. So first and foremost, what do we know about x and y? If this is a leg and this is a leg and this is a hypotenuse, we should know that x and y are equal to each other. So this, you should get the same answer for x and y, okay? Because the legs of a right triangle, the 45, 45, 90 triangle are going to be the same. So remember what we do to get from a hypotenuse back to a leg. So we're doing the opposite of what we just did. So instead of multiplying by root 2, we're going to divide by root 2. So I'm going to do 10 divided by root 2. We do not want to leave our answer in this form. So we want to rationalize our denominator. In other words, get that radical off the bottom. So to do that, we multiply this fraction, this ratio, by root 2 over root 2. So on the numerator, I get 10 root 2, and on the denominator, I get root 2 times root 2 is just 2. Keep reducing. 10 over 2, since those are both whole numbers, we can reduce to 5 root 2. And then remember what we said. If we know x is 5 root 2, since y is the other leg, they have to be equal, then y has to be 5 root 2. All right, that's a 45, 45, 90 triangle. Nothing too elaborate, but just have to kind of know those relationships. All right, so here's the next one. This is a 30, 60, 90, and there's really only two special right triangles, so there's not a whole lot for you to like commit to memory or to really kind of grasp. So in a 30, 60, 90 triangle, again, the 30 and the 60 refer to the angles. Obviously, 90 is the right angle. So you're going to have two different kinds of legs. Okay, so this is a 30-degree angle. The side across from this, I always label as my short leg. I just do SL for abbreviation. Remember, the smaller the angle, the smaller the side across from it. If this is 60 degrees, then this has to be my long leg, because it is the larger of the two. So unlike the 45, 45, 90, where the two legs were the same, we're going to have one leg that's shorter than the other. So I label it a short leg, long leg, and then of course the hypotenuse is still the side across from the right angle. So what the relationships are here, a little bit more complicated than the 45, 45. Everything is kind of surrounded by this short leg. So everything is kind of dealing with knowing the short leg of the triangle. So to get from the short leg to the hypotenuse, you would multiply by 2, not root 2. You would multiply by 2. So from the short leg to the hypotenuse. In other words, the hypotenuse is twice as big as the short leg, which is why this says 2x and this says x. To get from the short leg to the long leg, you multiply by root 3. So short leg to long leg, you multiply by root 3. There is no easy or direct relationship between the long leg of this 30, 60, 90 triangle and the hypotenuse. So we just kind of always use the short leg as its middleman. So if I was going from the hypotenuse back to the short leg, I would divide by 2. So I'm going the opposite direction. If I had the long leg and I wanted to get back to the short leg, I would divide by root 3. So let me give you 3 examples of how you will see this used. Okay, so just kind of wanted to cover all my bases here. So the first one, let's give you, you should be able to tell which one's the 30 and the 60 based off the drawing. But if you know, obviously the longer the leg, the longer the side. Let's call this y, let's call this x, and let's call this 3. So same deal, let's solve for x and y. All right, so you might notice that if this is the 30-degree angle, this is my short leg, which means this is my long leg, and this is my hypotenuse. So I always like to label all of my sides to begin with. And then I just follow the rules. So to get from short leg to hypotenuse, we multiply by 2. So that means 3 times 2 is 6. To get from short leg to long leg, we multiply by root 3. So 3 times root 3, again, leave it as a radical, is 3 root 3. And that's it. So there are a couple that get a little bit more challenging. So let me kind of give you some different scenarios here. So I'm going to give you 30. I'm going to tell you this is root 2, and I'm going to tell you this is y, and this is x. Okay, so first and foremost, I gave you that this is 30 degrees. So we should know that this angle has to be 60, right? Because in order for this to be 90 and this to be 30, there's only one possible answer, numeric value to have that equal 180. The other thing is I switched up the leg. So if this is 30 degrees, then this side is my short leg, this side is my long leg, and again, across from the right angle is my hypotenuse. So always pay attention to not only the way the triangle looks, but more importantly, what angles are across from it. All right, so x and y again. So this time I'm giving you the hypotenuse. So there's only one relationship we know, and the hypotenuse to short leg. So to get from the hypotenuse back to the short leg, we would go the opposite direction, which means we would divide by 2. So if the hypotenuse is root 2, if I divide by 2, I get root 2 over 2. So what that gave me is just the length of the short leg. Now that I know the short leg, now I can figure out the long leg. So from the short leg to the long leg, I would multiply by root 3. So I'm going to take 2 root 2, and I'm going to multiply by root 3. So you're going to have to do a little math here, right? So let's make this into a fraction. So when you multiply fractions, you don't have to have common denominators or anything fancy, but you do need to multiply across the top and multiply across the bottom. So I get root 6 over 2. All right, let's do one more example. I'm just going to kind of squeeze it in over here. Let's go this direction. So I'm going to give you, this is 60, here's a right angle, this is x, this is y, and this is 7. Okay, so what you should know is, again, if this is 60, then this has to be 30, because that's only one possible answer for that. This is going to be my short leg because it's across from a 30-degree angle. This is my long leg. This is my hypotenuse. All right, so x and y. This time I gave you the long leg, okay? So this is probably the more challenging of all 3 of the examples. So to go from a long leg, again, there's no direct relationship to the hypotenuse. So we're going from long leg back to short leg. We have to divide by root 3. So to get to x, I'm going from long leg back to short leg. I'm dividing by root 3. So I'm going to take 7 and divide by root 3. All right, so the problem here is that we have the radical on the bottom. So you do need to rationalize. So let's multiply the numerator and denominator by root 3 over root 3. So I get 7 root 3 over 3. This is how you need to write your final answer for that one. Again, no decimals, your answer in what we call reduced radical form. Now that we know the short leg, we can get to the hypotenuse. From the short leg to the hypotenuse, short leg to hypotenuse, we multiply by 2. So you're going to take 7 root 3 over 3, and you're going to multiply by 2. So again, the rule of thumb when dealing with multiplication with radicals is that you multiply, numbers with numbers, radicals with radicals. So across the top, you would get 7 times 2 is 14, and then root 3, and then on the bottom you would get 3. If 14 and 3 could have been reduced, then you would reduce it, but obviously in this case it can't, so that would be your final answer. All right, let's take a look at some extra practice. So this is on page 250. Let's take a look at some of these problems. I'm not going to do them all, but I thought maybe we'd do a few of these. So in numbers 1 through 4, it asks you to find the value of x, write your answer in simplest form. So I normally call this reduced radical form. Big Ideas uses the word simplest form, but again, it means the same thing. So I'm going to show you how I would do number 2. So I thought number 2 would be a good one for us to go over. So again, what you can do here is, if you notice, pay attention to what you're provided, right? If this is a 45-degree angle, you know this is a 45-degree angle. I want you to use your relationships. So show what work you can for all of these. If you know this side length is root 2 and this side length is root 2, okay, then you know that those two legs are the same length, which means this is a 45-degree angle and this is a 45-degree angle. So rather than using, what you could use here is Pythagorean theorem to figure out what x is, I want to challenge you to use the special right triangle relationships, which means if this is a leg and this is a leg and this is a hypotenuse, to get from a leg to the hypotenuse, you would multiply by 2. So I would get x to equal, so from a leg to hypotenuse, you multiply by 2. So then I'm going to go ahead and if I notice the 2's can cancel out, I get a final answer of 2. All right, let's see here. All right, next one, let's do one where we're given, let's look at the bottom here. So let's look at these ones. These are all going to be your 30, 60, 90. So let's look at number, I was thinking maybe number 7. Let's try number 7. So on number 7, what you're going to do is, again, kind of pay attention to what you're provided. If this is 30, this is 60. This is your short leg, this is your long leg, this is your hypotenuse. So I wanted to give you one where it was a little bit more challenging, all right? So this is where you're given kind of the long leg. So again, the only relationship we know between long leg is back to short leg. And what we know about that is we would have to divide by root 3. So I would get 9 divided by root 3. And so I'd get, on the numerator, I would get 9 root 3 over 3 on the denominator. Because again, root 3 times root 3 is just 3. I'm going to reduce those numbers, so I get 3 root 3 as my answer. To get to y, now that we know that this is 3 root 3, to get to the hypotenuse, we would just multiply by 2. So 3 root 3 times 2 would give me 6 root 3. So what I would like to challenge you to do is to kind of try these on your own right now. And I know that seems a little bit strange because, no one's paying attention or no one's making you do this, but I would challenge you to try 1, 3, 4, 5, and 6 right now. And then I'm going to give you the answers. So what I'd like you to do is pause the video, try 1, 3, 4, 5, and 6, and then unpause the video and see if you have the right answers. Okay? So go ahead and pause the video now, try these on your own, and now I'm going to go ahead and give you guys the right answers. All right, so hopefully you found this to be somewhat okay. This was a 45, 45, 90 triangle. So I got x to equal 10 root 2. For number 3, this was a 45, 45, 90 triangle. To get to x, because it's the same length for both those legs, I divided by divided by 2. So I got 4 root 2 as an answer. This was a 45, 45, 90 triangle as well. So to get from a hypotenuse back to a leg, I divided by, whoops, I think I did that wrong. I'm sorry. We divide by root 2. That makes more sense. Sorry, divide by root 2. And so if I divided by root 2, I would get 8 as my answer. And then this one, to get from a hypotenuse back to a leg, we would divide by root 2. So again, we'd have 12 root 2. Let's rationalize. So I would get 12 root 2 over 2, and so then this would give me 6 root 2. So I think I did this one wrong. We did root 2 over 2. To get to the hypotenuse, we would multiply by root 2. And so I multiplied by 2. So if you were wondering on that one, I did make a mistake. So let's do this one. So I'm going to redo number 2. For those of you who caught that, I just now realized. So for number 2, I had the wrong, for whatever reason, I was thinking of it incorrectly. This is from the leg to the hypotenuse. We would multiply, so we take 2 root 2, and we multiply by root 2. So I would get root 2 times root 2, which is 2, and then 2 times 1 is 2, which means I would get an answer of 1 for number 2. So sorry about that. At least I caught it and made the correction. So you can, if you found that, great. All right, let's look at number 5. So this is your 30, 60, 90. So short leg, long leg, hypotenuse. So the x value I got to be 15 root 3, and the y value I got to be 30. Again, just following those relationships. So again, this is a 30, 60, 90. This time this is the hypotenuse, this is the long leg, and this is the short leg. So it's easy to go from hypotenuse to short leg. You would just divide by 2. So y has to be 11. And then from short leg to long leg, you would multiply by root 3. So you'd get 11 root 3. All right, so hopefully you did okay on that. If not, again, there's more practice on big ideas. I encourage you to come to class with all kinds of questions if you have them. Again, this is kind of an important topic, especially the special right triangles one. We need to be really good at it. So if you're struggling a little bit, keep practicing, ask questions, come in for Blackhawk Hour to get some support. All right, bye for now.